Hello friends, welcome back to VOWIAS. Welcome to the Prelims test series discussion of Vision IAS. So as we are discussing the test 3, this is part 2 of this test 3. In the part 1 we have discussed from question number 1 to 35, and now we are going to continue from question number 36. So before we begin, a small information. You can check the quality of these summaries that we are providing in our Telegram channel. All the documents that we are using for the discussion are the summary documents prepared by VOWIAS, and these summaries of Vision IAS test series of prelims and mains and the monthly magazine are available for subscription. You can check the details in the Telegram channel. Now let's begin with the question number 36. So the 36th question, if you see, this is with regarding to Biological Weapons Convention. So the Convention on Prohibition of Development, Production and Stockpiling of Bacteriological, that is biological and toxin weapons on the destruction, negotiated by the Conference of Committee on Disarmament in Geneva, is open for signature in 1972 and enforced on 26 March 1975. So basically this Biological Weapons Convention is nothing but prohibition of the use of these biological weapons in the warfare. So this is according to the 1925 Geneva Protocol, and it prohibits the development, storage, acquisition, transfer of all these kind of biological and toxin weapons, because these biological weapons will kill the humans at large scale in a very short span, and it will impact the entire humanity. And the first multilateral treaty banning the entire category is the WMD, Weapons of Mass Destruction. So this is about the Biological Weapon Convention. Next is the Green Hydrogen Microgrid Project. The 37th question, Green Hydrogen Microgrid Project. So recently NTPC was awarded India's first green hydrogen based microgrid project at Simhadri in Andhra Pradesh. It helps decarbonizing the far off regions, example Ladakh, and meet the clean energy goals. The hydrogen does not naturally exist as gas in usable quantities occurring in compounds like water, and it must be produced using the industrial methods. The green hydrogen, if you see, it is produced by splitting water into hydrogen and oxygen using electrolyzer powered by renewable sources like wind and solar. So the hydrogen microgrid project basically is a green hydrogen project. So what is green hydrogen? The hydrogen which is produced from renewable sources, that is called as green hydrogen. We will have various kinds, green, blue and all. So what does green means? The hydrogen which is produced from renewable sources. So renewable sources means you can use either solar energy, you can use either wind energy, so whatever. If you use all these energies in the production of the hydrogen, then it is called as green hydrogen, right? And the hydrogen which is produced by splitting, so basically hydrogen is produced by splitting of water molecule into hydrogen and oxygen using electrolyzer powered by renewable. So how the reaction takes place is water is taken and here 2H2 plus O2, right? So hydrogen and oxygen will be produced and oxygen will be released into the atmosphere. So this oxygen which is released into the atmosphere does not cause any harm, and this hydrogen which is produced will be used. Right. So overall, if you see, this is a very clean technology. This is still in the developmental phase, but the thing is that as of now the production cost is very high. So if we can bring down this production cost, this will be a great boost. So that's why these things are important. So this NTPC was awarded the India's first green hydrogen based microgrid project at Simhadri in Andhra Pradesh. Remember, NTPC of Andhra Pradesh, green hydrogen microgrid project. Next, some important terms like soil fluxion. So this is nothing but the slow downslope flowing soil masses or fine grained rock debris, the saturated or lubricated with the water. So soil fluxion, in simple words, it is nothing but the movement of these fine soil particles, fine rock particles along with some water, that is called as soil fluxion. But earth flow, if you see here, the clay will move along with the water. So the water saturated clayey and silty earth material will move along the hill slopes, that is called as earth flow. Slump, if you see, slump is nothing but it's a type of landslide. It's a type of landslide where there will be rapid and perceptible material and dry slipping. So that means even without water also the land can move. So it's a kind of landslide in simple words. But soil fluxion is nothing but the rock debris and all will move along with some water. And the earth flow is directly the upper part that is the clay and the soil, it will move directly along with water, that is called as earth flow. Next, 39th question is on the temperature at oceans. So temperature of oceans, if you see, it fluctuates with the seasons. And also another thing is that there will be temperature gradient from the surface of the ocean till its bottom. The maximum temperature of oceans, if you see, it is always at the surfaces. As we go deeper, the temperature will fall, and the heat is transmitted to the lower sections through conduction. So there are three modes of heat transmission: conduction, convection, and radiation. So here through conduction, because the layers are in contact, there will be movement across these layers. Okay, so temperature structure of oceans, if you see, there is this three layer system. The first layer is the top layer, which is 500 meter thick with temperature between 20 to 25 degrees centigrade. The second layer is thermocline, where there is rapid decrease in temperature with increase in depth. So in the first layer, which is 500 meter thick, the temperature will be similar at 20 to 25 degrees. But below that, there will be rapid decrease in this temperature with increase in depth. So this second layer, thermocline, is also about 500 to 1000 meters thick. And the third layer is extremely cold. It extends even up to the ocean floor. And the average temperature of the oceans is about 27 degrees centigrade, and it decreases from equator towards poles. Oceans in northern hemisphere record relatively high temperature than the southern hemisphere, and the highest temperature is not recorded at equator but slightly towards north of it, because near to the equator there will be rainfall, there will be huge rainfall. So because of those reasons, right? So these are the three layers. So the first layer, it is about 25 to 26 degrees centigrade. And also, if you see the hot water, that is the water which has more temperature, is less dense compared to that of the cold water. So hot water will be at the top. So all these things. Next, Himalayas. Himalayas, if you see, they are the northern protectors, or you can say the barrier which protect India in the north. It is the Himalaya. So like this, the Himalayas will be there. So as you all know, and these Himalayas are an effective climate divide, protecting the subcontinent from cold and chilly north winds. These Himalayas trap the monsoon winds, forcing them to shed their moisture within the subcontinent. That means all these monsoon winds, the southwest monsoon which will come like this, so they will not cross these Himalayas. They will not be able to cross these Himalayas, and they will rain throughout the India. Okay, and another thing is that the cold Siberian winds which are coming from the north, the Himalayas won't let them enter into the Indian subcontinent. So this will ensure that the Indian continent will remain at a much better climate, or it will have much better climate, and the temperature will be at a safe level where people can happily live. That means the moderate climate will be maintained. Because otherwise, if these cold winds enter India, then all the climatic pattern will get disturbed, and the rainfall pattern will get disturbed, and also people will not be able to live in a you can say comfortable climate, in simple words. Right. This is the thing about Himalayas. Next, the peninsular region. Next question, the 41st question is on the peninsular region. The peninsular region consists of Aravalis, the Satmala, Ajanta, Mahadev, Michael, the Kaimur, the Garjat, all these things. And the relative order, if you see, the Satmal, Mahadev, Kaimur, Ramgarh. So this is the order. So here you have the Satmal, so Mahadev. Okay, so here you have Ramgarh, you have Kaimur. So this is the order. In the map you can see. So this is about peninsular region. See, this Himalayan region, peninsular region, these are very important. If you have very clear idea about these maps. Where does these hills exist? The Ajanta range, the Balghat range, the Dandakaranya region. You have to have a clear picture of all these things, clear idea about all these things. These are very important, because in exam sometimes they are asking match the following, or they are asking like the relative order from north to south, east to west, like that they are asking. So you have to know very clearly where is Aravallis, where is this Malwa Plateau, all these things. So read this Indian geography very carefully. The NCERT, if you can have a grip over the NCERT, that will be sufficient. Next is salinity. So just now we have seen we have seen this ocean temperature. Okay, so now here this question, 42nd question, is about ocean salinity. So salinity, if you see, it is nothing but the salt content, right? So as you all know, near the equator we will have more rains. So when there is more rains, the water will be more diluted. So the tropics receive more rains, so thus the salinity will be less. Thus there will be decrease in salinity. The salinity is lower than 35 ppt in equatorial waters. The lower salinity water rests above the higher salinity dense water. So the hot water is less dense, and also the less saline water is less dense. So more salinity means more dense, it will be at the bottom. The cold water will be more dense, it will be at the bottom. Okay, so because of this salinity difference, because of these temperature difference and all, there will be differences in the densities, and there will be relative movement of water, and these will cause these currents, ocean currents. Okay, so this is the thing. And also average salinity of Indian Ocean is approximately 35 ppt is parts per thousand, and the lower salinity trend is observed in the Bay of Bengal due to the influx of the water from river Ganga and Brahmaputra and all these major rivers. And the Arabian Sea show higher salinity due to high evaporation and lower influx of fresh water. Right? So this is the thing. Next, 43rd question is on the important cities. So important cities: Jaipur. Jaipur, if you see, it is the capital of Rajasthan, and it is also the largest city of Rajasthan. It is at 75.8 degrees east longitude. Bhopal, the capital city of Madhya Pradesh, at 77 degrees longitude. Lucknow, the capital city of UP, at 80 degrees 57 minutes east longitude. Raipur, the capital city of Chhattisgarh, is at 81 degrees 63 minutes east longitude. So these are the important cities. Next, temperate continent climate, the steppe climate. So this temperate continental steppe climate, if you see, this is a temperate climate, and also since steppe as an it's a grassland. Steppe is the grassland, and where there is cold winters and warm summers, you will be able to find this. And though they lie in the westerly wind belt, remote from marine influence and practically treeless, in the northern hemisphere, these grasslands are far more extensive and are continental. And the Eurasia also, you can find these. They are called steppes, and they stretch eastward from the shores of Black Sea across the giant Russian plain to the foothills of the Altai mountains, all across the distance of about 2000 miles. In the southern hemisphere, there is this maritime influence in the steppe type of climate, and its annual precipitation is always more than average 20 inches because of the warm ocean current that wash the shores of steppe lands here. And there are 3 months, June, July and August, where there is no rain. So this is a period of drought. The dry season is there, and the pronounced and temperate grassland adjoining the deserts, for example in Australia. So these grasslands, they are near to that of the deserts, you can say. They are in the places where there is this dry season particularly, and also the rainfall will be less in these regions. That's why if you see these in the Asia, in this especially in the Central Asian region, you will find these things, the Eurasian Central Asian regions, right? That is the thing about the steppe. Next, 45th question is on the atmosphere. So the atmosphere is, if you see, it consists of gases, water vapor and dust particles. The proportion of gases changes in the higher layers of atmosphere, like the oxygen, and this oxygen will be almost negligible in quantity at about 120 kilometers. Similarly, the carbon dioxide plus water vapor, they are found only up to 90 kilometers from the surface of the earth. The ozone, which is found between 10 to 50 kilometers above the earth's surface and absorb UV rays radiating from the sun and prevents them from reaching the surface. So if you see the constituent of the atmosphere, nitrogen is the highest, about 78% of nitrogen you will find in the atmosphere. It is the highest quantity, it is present in highest quantity. After that you have oxygen, after that you have argon and carbon dioxide. Remember these four: nitrogen, oxygen, argon and carbon dioxide. So if you see the atmosphere, these are the important gases, and from the lower atmosphere to upper atmosphere, if you go, there are different layers, like the troposphere, stratosphere, mesosphere and thermosphere. Okay, so this CO2 plus water vapor, they are found only up to 90 kilometers from the surface of the earth, and ozone is found between 10 to 50 kilometers. Okay. So these are some of the important facts. Next, there are also inert gases. Inert gases means nothing but these gases don't react with other substances. For example, helium, argon, neon, xenon, krypton, radon, etc. Right. So next one is the molasses basin. So molasses basin is the thick association of continental and marine clastic sedimentary rocks. It consists of sandstone and shales from the shore deposits. So Mizoram, if you see, it is made up of these soft unsolicited deposits. This is about the molasses basin. Right. Next is about the countries at the Mediterranean Sea. So this Mediterranean map is very important for us for the prelims. So this Mediterranean Sea, if you see, towards the south, that means you have the Africa. Towards the south of Mediterranean, you have the Africa. So towards the north, you have Europe here, and towards its right side, you have this Asian region as well. So the African countries which border Mediterranean Sea, so Talim is the shortcut. So Tunisia, A for Algeria, L for Libya, right? M for Morocco. So this is the E for Egypt. Egypt will be here, and M for Morocco. So Thalem is the shortcut. Thalem. And if you see Asian countries, LICS, L stands for Lebanon, I stands for Israel, C for Cyprus, and S for Syria. These 4 countries, it will border the Mediterranean Sea. And also here you have the Turkey, the Asian part of Turkey. Okay, that also will be bordering the Mediterranean Sea. Here you have Albania, Greece, Montenegro, the Croatia, Slovenia, Italy, Monaco, France, Spain. So all these countries also border this Mediterranean Sea. So this is about the Mediterranean Sea, and this is very important for the exam, so prepare it well. Next is the Vigil mission. The Vigil mission, it is formerly known as the Lagrange. It is in the European Space Agency, Space Weather Mission. So this Vigil mission is the European Space Agency, the ESS weather mission. It will monitor our active and unpredictable sun to protect it from to protect all the vital infrastructure which is there in the space. It will give us advanced warning of the oncoming solar storms, placed in 5 Lagrangian orbits, the positions in space where gravitational forces of 2 bodies like Sun and Earth produce enhanced regions of attraction and repulsion, and it can be used by the spacecraft to reduce the fuel consumption needed to remain in the position. This is about the Vigil mission. Okay. Next, semiconductors. Semiconductors, if you see, their supply increased due to COVID. Sorry, their supply actually took an impact during this COVID. The semiconductors are these chips, or you can say they are these important materials. These important materials which are used in almost all the electronic devices. So their supply was impacted during this COVID. Semiconductor are the materials comprised of the silicon, and it conducts electricity more than an insulator like glass, but less pure than the conductors like copper and aluminum. That's why it's called semiconductor. They are very important in all these electronic devices. They fall into 4 main categories: the memory chips, the microprocessors, the commodity integrated circuit, the complex SoC, the system on chip. So these are various things. Next, the 50th question is on boundaries. 50th question is on boundaries. So as you know, the earth is made up of various plates according to this plate tectonic theory, and here when these plates come together, or when one plate is going above another plate, so that means 2 plates are coming together, it is called as the convergent boundary. So in this convergent boundary, what is happening? One plate is coming above another plate, so there is destruction of a plate that is happening, so it is the destructive boundary. The convergent boundary is a destructive boundary. Whereas if you see, you have this divergent boundary where 2 plates are going away from each other like this. So here what will happen is that there will be a volcano and the lava will come out of this when the 2 plates are move away from each other. So here new plate is being created, and this is called as constructive boundary. So divergent boundaries are constructive, whereas convergent boundaries are destructive. Right? Convergent boundaries are destructive. So this constructive and destructive boundaries, if you see, like this. And also there is another boundary called the transform boundary. Yeah, before that, one more information. This divergent boundaries we will find in this mid-oceanic ridges. This is a classic example. Next, the transform boundary. Transform boundary means the 2 plates will be slipping against each other when the crust is neither produced nor destroyed as the plates horizontally past each other. So something like this. Right, 2 plates are there, one is moving like this, another is moving like this, something like this it will be there. Okay, that is called as transform boundary. Okay, so transform faults, the planes of separation perpendicular to the mid-oceanic ridges. Those are the things. Next, 51st question is on the intertropical convergence zone, the ITCZ. The ITCZ, if you see, it is a low pressure zone at the equator where the trade winds converge, and the air tends to ascend. That means it will go up. So the location varies with the seasons. In July, the location is about 20 degrees north to 25 degrees north latitude. That means near to the Gangetic plain, and it is called monsoonal trough, and it pushes the development of the thermal low over the north and northwest India. So this shift of ITCZ actually impacts the trade winds. And also what it will do, it will create these low pressure areas, and also this will lead to more of these kind of cyclones, because the low pressure develops somewhere near the ocean, there will be cyclones that will be developing, because cyclones need this low pressure. Okay, so that is the thing. And also in winter the ITCZ will move southwards, so it reverses the winds from the north and northeast of India to the south and southwest, calls the northeast monsoon. So the emergence of this southwest monsoon and southwest monsoon and northeast monsoon over the Indian subcontinent has link with this ITCZ, that means if you see this is India, so here the ITCZ will be somewhere over this northern India, and as here there will be low pressure, the winds from here over the ocean, Arabian Sea, this is the Arabian Sea, just a second, yeah, this is the Arabian Sea. So from the Arabian Sea the winds will be coming towards India, because wind will move from high pressure to low pressure. So here there is this low pressure, why? Because of this ITCZ. So during the summer months, that means just immediately after these summer months, the monsoon wind will be moving from the Arabian Sea towards the northern subcontinent. Later on in winter, what will happen? This ITCZ, it will move downwards. So that means the low pressure zone will be somewhere near to the, you can say, in the ocean. So here the low pressure is here and high pressure is here in the North India. So here the winds will start moving from north and northeast towards this ITCZ. That means this is the northeast monsoon, you can say, right? So this is how winds move during the southwest monsoon and northeast monsoon. Next 52nd question is on the Bosphorus Strait. So Bosphorus and Dardanelles Strait. So Turkey to implement international convention on naval passage via Bosphorus and the Dardanelles, and it would allow them to limit these Russian warships and the movement between Mediterranean and Black Sea. The Bosphorus and Dardanelles connect the Aegean and Black Sea via the Sea of Marmara, the only passage by which the Black Sea ports can access the Mediterranean and beyond. So Bosphorus Strait, if you see, this is the Bosphorus Strait, and it is a natural strait connecting the Black Sea to the Sea of Marmara. Its length is 32 kilometers. So here you can see this is the Black Sea and this is the Sea of Marmara. So Black Sea, the countries surrounding this Black Sea are Russia, Ukraine, Georgia, Turkey, and so on. Okay. So this Bosphorus, if you see, it is a natural strait connecting this Black Sea and Sea of Marmara, 32 kilometers long. It separates the European and the Asian part of Istanbul, that is Turkey. So this is the European part of Turkey and this is the Asian part of Turkey. This Bosphorus Strait is dividing these two. Okay, so Bosphorus Strait, remember, it is between, or you can say it is in Turkey, between the eastern and western part of Turkey. So this is about this Bosphorus and Dardanelles and the Bosphorus Strait. Next, Brahmaputra, it is also another important thing for us, the Brahmaputra river in the northeast region. The Brahmaputra originates from the Chamayangdang glacier of the Kailash range near the Manas Sarovar lake. It is called as Sangpo, the Yarlang Sangpo. It is called Yarlang Sangpo in China, and it reaches India via this Namcha Barwa. So it somewhat originates and travel through Tibet, and like this it will enter into India because of this mountain called Namcha Barwa. Okay, near this Namcha Barwa it will take a turn towards the south and it will enter Arunachal Pradesh. It emerges from the foothills under the name Siang and it enters India from Arunachal Pradesh. The left bank tributaries are Dibang, Sikand and Lohit. Therefore, it is known as Brahmaputra. Its major left bank tributaries are Burhidihing, Dhansri, and the right bank tributaries are Subansri, Kameng, and Manas and Sankosh. These are the right bank tributaries. The Brahmaputra enter into Bangladesh near Dhubri and flows southward. In Bangladesh, Tista joins it on the right bank, where river is known as Jamuna. It finally merges with the river Padma, which falls into the Bay of Bengal. Okay, so this is about Brahmaputra. So Brahmaputra will merge into the Bay of Bengal after merging with the river Padma. Next, 54th question is on the monsoon of Indian Peninsula. So the monsoon of Indian Peninsula, if you see, it is because of the southwest winds and the northeast winds. These two are the typical monsoon causing winds. India is flanked by Indian Ocean on three sides in the south and grilled by a high and continuous mountain wall in the north. So as compared to the landmass, water heats up and cools down slowly. This difference in the heating and cooling actually creates a difference in the pressures, and there will be movement of the wind which creates these monsoons. So just now we have seen when the ITCZ is on the top of India in the north, in the northern region during the summers, there will be movement of these winds because the winds above ocean will be of higher density, and the hot winds at this ITCZ will be of low density, and this difference in density will let the movement of these winds from the Arabian Sea to the North India. Okay. So this is how the monsoon winds will flow across the India because of this ITCZ. Next, the Kareva formations. Kareva formation. So the Kareva formation is famous in the Himalayan region. Kare means the thick deposit of glacial clay and other materials in the moraines. It is useful in the cultivation of saffron, which is a local variety of saffron. So the Kareva is nothing but the thick deposition of glacial clay. Remember this. So and also this is famous in Kashmir, in the Kashmir Himalaya. Right. Next, the 56th question is on the equatorial type of climate. So the important thing here is that there is great uniformity of temperature throughout the year. The temperature will be hot throughout the year. There is no winter in the equatorial region. The sun will be the sun, you can say it will almost be above them. It will just sun will just move here and there across the latitude, but almost the sun will be above them all throughout the year. There will be cloudiness and heavy precipitation also around throughout the year. Diurnal range of temperature is also very small. That means the difference between the maximum and minimum temperatures will be very small, as there will be no winters, but the vegetation will be too huge. There will be too much of vegetation because of these excess rains. And the tropical rainforest is called selvas. The smaller palm trees, climbing plants like lianas and rattans, which may be hundreds of feet long and epiphytic, and the parasitic plants live on another plants. The wide variety of ferns, orchids, the lalang live under the trees. The tallest trees attain a height of above 150 feet. Okay, so this is about the equatorial type of climate. 56th question. Next, 57th question is on the important biosphere reserve. The important biosphere reserves of India, if you see. So the biosphere reserve, the first one is the Achankmar Amarkantak Biosphere Reserve. It is in Chhattisgarh and Madhya Pradesh. So it has it is the source of three major rivers, the Narmada, Johila and Son. It is a UNESCO designated biosphere reserve. It was designated by the UNESCO in 2012. The Achankmar Amarkantak Biosphere Reserve. Next is Shimlipal in Odisha. It's a national park plus tiger reserve. It is part of the Mayurbhanj Elephant Reserve. It has three protected areas: Shimlipal Tiger Reserve, the Hadgar and Kuldia Wildlife Sanctuary. Shimlipal National Park derives its name from the abundance of red silk cotton trees in area home to the Bengal tiger, Asian elephant, Guar and Chusinga. Right. Next is the Agasthyamala Biosphere Reserve, set up in 2001, and it includes 3,500 square kilometers, of which 1828 square kilometers in Kerala, 1672 in Tamil Nadu. Agasthyamala in Kerala. Okay, you can say it's a mix of Kerala and Tamil Nadu. It is also part of the UNESCO World Network of Biosphere Reserve. Next is Panchamarhi in Madhya Pradesh. It is in the Satpura range. It forms a watershed between the Narmada to the north and river Tapi to the south. It's also designated by UNESCO in 2009. It includes three wildlife sanctuaries: the Bori, Panchamarhi and Satpura National Park. So Panchamarhi in Madhya Pradesh, the Agasthyamala in Kerala, Tamil Nadu region. You have the Achankmar Amarkantak Biosphere Reserve. This is also in Chhattisgarh and Madhya Pradesh. Shimlipal in Odisha. So these are the various things. Next question is on the important rocks. The 58th question is on important rocks. So tillite, if you see, tillite is a sedimentary rock. So where there are different layers of deposits, glacial deposits especially. Okay, at the base the system has a thick tillite indicating extensive and prolonged glaciation. The counterparts of this succession is found in Africa, Falkland Islands, Madagascar, Antarctica and Australia besides India. Provides unambiguous evidence of the paleoclimates and drifting of continents. The pumice, if you see, it's a very light and porous volcanic rock formed when a gas-rich froth of the glassy lava solidifies rapidly, and it is an igneous rock, the pumice. Next is the marble. The marble is a metamorphic rock composed of recrystallized carbonate minerals, the calcite and dolomite. Next is the quartzite. So the metamorphic rock formed when quartz-rich sandstone and sherd has been exposed to high temperature and pressure. So tillites, so these are the various rocks. The marble is a metamorphic rock, tillite is a sedimentary rock, the pumice is a volcanic rock, it's an igneous rock. In fact, pumice, as the name suggests, okay, something it's like a igneous one. The quartzite is also a metamorphic rock, right? So metamorphic rock means the rocks, the original sedimentary or igneous rocks, they are transformed because of the application of heat and pressure. So these are the various rocks. Next, the 59th question is on the drainage system. So drainage system is nothing but a channel, well-defined river channel. That is, so all these things are, so these well-defined river channels are nothing but part of this drainage system. The drainage pattern, if you see, it is the outcome of geological time period, nature and structure of rocks, topography, slope, amount of water, periodicity of flow. The different types of drainage patterns are dendritic, it resembles the branches of trees, example the Himalayan rivers. Radial means the river originating from the sea. Just a second. Yeah, sorry. So radial means the river originating from a hill, and flowing in all directions. So for example, something like this, river originating and flowing in all these directions. This is the hill here. Okay, that is called as radial. The rivers originating from Amarkantak are this kind. Next is trellis. So trellis means there will be when the tributaries of the river flow parallel to each other, something like this. Okay, so these are the two tributaries, they are flowing parallel to each other. They will join the main river somewhere. Okay, this is the main, let's say this is the main river. These parallel tributaries, they will join the main river somewhere. Something like here, they can be like this or like this and all. Next, the centripetal, when the river discharges their water from all directions. That means this is the river, and here this is the main river, and the various branches flow like this. So here the example is Loktak Lake in Manipur. So these are the various ones. So dendritic means something like a tree branch. So it will be layered like this. Okay, this is called dendritic. Next, the radial means, as just now we have discussed. So all the rivers will flow in various directions from a single point. Okay, example the Amarkantak range. Next is trellis. Trellis means parallel tributaries joining the main river. Next, centripetal means rivers discharge into a single lake, you can say. Example, Loktak Lake. So these are the various drainage patterns. Next, the Earth's crust. If you see, it is the outermost thinnest layer, thickness of about 30 to 50 kilometers. The continents are composed of light silicates, silica and aluminum, called sial, and made up of granite rock, while oceans have heavy silicates, silica and magnesium are called sima. Okay. So here the continents are made up of the sial, silica and aluminum, and the oceans are made up of sima, silica and magnesium. And also you have the various discontinuities. Okay, the various discontinuities are the Moho discontinuity between crust and mantle, the Moho, right, the Conrad, the Gutenberg discontinuity. So all these are various discontinuities that you have, right? Let's move on to the next question, the 61st question, which is about humidity. Humidity, if you see, humidity is nothing but the amount of water vapor that is present. And absolute humidity stands for actual amount of water vapor present in the air. It is expressed in gram per meter cube. It is the actual humidity. Next, the relative humidity. Relative humidity is the ratio between actual amount of water vapor and total amount of air that can hold up at a given temperature, expressed as a percentage. That is called as relative humidity. So relatively how much it is there. Okay, so relative means ratio between actual and ratio between the actual amount of water vapor the total air can hold at a given temperature. Sorry, it is nothing but the what is the present humidity that is there compared to that of the humidity, the whole humidity that this water vapor can hold. That is the relative humidity. So relatively how much it is having. Okay, so maximum, let's say maximum is 100 gram per meter cube, and currently it has 10. So this relative measurement is nothing but relative humidity. So the warm air can hold more water vapor compared to that of cold air when the relative humidity reaches 100. So warm air can hold more air because cold air generally is saturated. So saturated means it cannot hold more water vapor. So that is the thing about humidity. Now let's move on to the 62nd question, which is about the antimicrobial resistance. So UNEP report released on the sideline of the 5th session of UNEA identified 5 major contributors to global development. The major sources are the poor sanitation, sewage and waste effluent and waste from pharmaceutical, effluent and waste from healthcare facilities, use of antimicrobial and manure in the crop production, the releases the effluent releases and waste production, etc. These are the major sources of this antimicrobial resistance. The water, soil, and air, they serve as a vehicle for the spread of these antimicrobial resistant microbes, because humans will come into contact with this soil, air, and water very easily, and they will spread to humans and animals. That is about this antimicrobial resistance. Next, the 63rd question is about the circular shape of planetary bodies. So planetary bodies, if you see, most of the planetary bodies, they are circular in shape. Sun, moon, the earth, other planets also. So this circular, if you see the circular motion, the circular shape is because of various factors like the motion, the centripetal motion, and all of the other along with this motion, just a second. Yeah. So along with the motion, there are forces also. So this motion plus forces, they ensure that these bodies become circular in shape. So the distant horizon viewed from deck of a sea ship or from a cliff is circular in shape. It widens with increase in altitude and could only be seen on a spherical body. So, and also the sun sets and rises at different times at different places. The sun sets and rises at different times at different places, and as the earth rotates from west to east, the east sees sun earlier compared to that of west. But if earth was flat, the world would have seen, or you can say the whole world will see the sunrise and sunset at the same time. So these are the various proofs saying that the earth is round and not flat. During the lunar eclipse, the shadow cast by the earth on moon is always circular. This was also observed. Only a sphere can cast such a shadow. So these are the various observations which told us that most of these celestial bodies, they are circular in shape. As they are rotating around the sun, the forces of gravity acts on it. Okay, the centripetal forces will be there. All of these things ensure that the excess of these particles are removed and they remain circular in shape. That is about the circular shape of planetary bodies. Next, meander. So meander, if you see, it is nothing but the channel-like patterns over the flood and delta plain, that is called as meander. They associate with the river in old stages. The factors responsible for formation of meanders, if you see, the propensity of water flowing, okay, the unconsolidated nature of alluvial deposits making up banks with irregular, which can be used by water exerting pressure laterally, the Coriolis force acting on the fluid, deflecting it just like wind. And also this meandering is formed by the Jhelum due to the local base level of sediments. The rivers form meander in their mature stage, but Jhelum flowing through Kashmir forms the meander even in the youth. So meandering means nothing but rivers turning like this. So that is called as meandering. Next, 65th question is about the India and Bangladesh protocol route. So recently Brahmaputra generally, if you see, it is connected to Ganga river via India and the Bangladesh inland water transit and the trade protocol route. So a ship which has to go to Brahmaputra will travel through this route. So the vessel started sail from Patna on National Waterway 1 and pass via the Bhalgapur, the Manihari, the Sahibganj, the Farakka, Tribeni, Kolkata, Haldia, Hemnapur into the Indo-Bangladesh protocol via the Khulna, the Narayanganj, the Sirajganj, the Chilmari, and the National Waterway 2 through Dubri and Jogigopa, covering 2350 kilometers. Okay, so this is the route. It is under the ambit of Inland Waterway Authority of India. It is under the second addendum on the protocol on the inland water transit and trade between India and Bangladesh. So see, this National Waterway 1 and Waterway 2, they are very important for the transportation. These river transportation, they cost very less. They are about 20 to 30% of what actually is the price for the transportation over the rail. Road transport is again very costly. So this inland waterway routes will ensure that the connectivity between the regions of mainland India and the northeast India, because a ship or cargo which has to go to northeast can travel through this inland water road, will go into this route, and from Ganga it will reach Brahmaputra, because at the end of the day, if you see, the Brahmaputra will merge into this Ganga in the Bangladesh. Okay, so this is the thing about this. Protocol on inland water transit and trade between India and Bangladesh 2020. Right. So these are the questions for the day. Tomorrow we will discuss the next set of questions, right? And before I leave a small information, so we are providing these summaries which are available to you for subscription from our Telegram channel. You can subscribe to them, and if you can also comment in the comment box for more information on these courses and all, right? So that's it, guys. I'll see you again tomorrow with the next set of MCQs. Till then, keep studying and stay tuned. Jai Hind.